Alright, let's begin. So to start off, I'm going to be Start off, I'm going to be showcasing the bullet life cycle to show that game object life cycle works. So as you can see here, we have all the different bullets. If we were to load in a bullet, you can see that we're constantly cycling them for the enemies. The enemies are never calling this part of the function because they have bullets in their reserves. If I were to put a breakpoint right here, we can see that it's starting to pull specifically from the reserves and never from the life cycle, or never the new part. Beyond that, need to continue it. Okay, so beyond that, this is the actual scene itself. We have the amount of tanks in the scene in the upper left, directions in the middle left, start button, title screen, and if I press the V key, we have the sound settings. So if I were to set this lower, you can hear the sounds quieter. I can raise the volume, mute, and then mute it again, lower the volume, unmute, it plays at that lower volume. If I were to start the game, we can see that the settings persisted. So if I were to just, move over here, these are all working as intended. So over here, crash that. We have this exclamation point. This always points to where the nearest tank is relative to the player. This allows you to know where you need to rotate to face the next tank. So now the next tank is behind me to the left, right over there. And if I were to try and position myself to be closer to the other tank, it will eventually update itself to look at that tank instead. And once I clear out all the tanks, we can move on to the next level. So the next level has yellow tanks. These yellow tanks behave slightly differently than purple tanks in that they don't care about the player until they get too close. So as you can see, this one is moving away from the player, but now that I'm close enough, it's changing its direction to approach me. So you can see that again over there. The tanks to the left are not approaching me. Now that I'm close enough to this tank, it is approaching me. And then once again, the nearest tank is always updating to make sure it is the one nearest to the player. So even though that purple tank was technically closer to me, because I moved away far enough, now this yellow tank is closer. And then once I clear out all the tanks, I get a victory screen. The score here is based on how long it took you to complete the game. Pressing the main menu takes me back to the title screen, and then I can start playing again. So just let me go over here to showcase the game over scene. So if I just walk over here, let this guy hit me a few times, I can showcase what the game over state for the game to show that it is properly completed with the transitions and everything. So here we have the game over. Gotta press retry on main menu. If I press retry, it takes me out to the level. For speed's sake, now that I show the transition worked, if I were to load this up on the game over scene again, and main menu takes you back to the title scene. Alright, so to start things off, we have the settings management. This is a singleton that is handled between scenes and is responsible for passing the settings into each scene. So we have a settings class here that attaches itself and detaches itself to the settings manager based on creation destroy. Whenever we attach it, it passes in whatever settings the singleton has to that to that little settings here. And whenever we detach the settings from the scene because we're about to swap, we give the settings manager what the last data was that was stored in it. We have this little class here because we want to be able to open up and close a menu. So we use the inputable for that. This is why we can't use the singleton because singletons aren't game objects. And we have a settings to canvas to open up the audio slider and the mute button. Whenever we press the V key, if the canvas is currently active, then it would detach it from the scene. Otherwise, it will attach it to the scene and set the canvas active to true. I'll cover this a bit more when I discuss my UI demo, but the general gist of it is we pass through these settings using the two components here. The audio slider, which will return a float value whenever the percent is updated, and the mute button, which will tell the settings whether or not the game is muted or not. And then it will update the sound player to either mute or unmute, or to set the sound volume here. Beyond that, there's also setting the start time of the game. This is specifically to calculate the score. So in level 1, when you initialize level 1, you set the start time. The start time is just whatever the current game time is of the game. And then on the win screen, the score is then computed to be nope, that's the canvas. The interact is what I'm looking for. Your score is whatever the time is when you enter the scene minus the time you started with. Then the canvas is, this is just a button to return you to the title screen. That is the start game button. No, that's the return to title button. I know my names. So return to title moves you back to the title screen. Both the win screen and the game over scene have this. So I will hop over to the game over canvas. This also has a start game button over here. Return to title button. It also has a start game button, as does the title scenes canvas. And these are the ones that send you into the level 1. So if I were to just pop back down here, return to title, send you to title scene, start game, send you to level 1. Beyond that, level 2, nope, we want to start off with the player. So for the player represents how many lives they have. So we have a little heart icon to represent that. Whenever we take damage, we decrement our life counter. If we ever reach 0, we then go to the game over scene. Drawing is drawing 2D, where we just draw the life counter based on however many lives we currently have. The HUD, which is up here. HUD represents how many tanks are currently in the scene. Whenever a tank is added or removed by the tank spawner, it will call the necessary updates here. And these updates will update the strings for red, purple, and yellow. For the objective setter, this allows us to determine what we need to do to make it to each scene. So we inside each level, we will determine what the objective is. So if I were to bounce back down to level 1, you can see that the objective is set to be getting everything to 0. And when that is done, we will move to level 2. So bouncing back over to here. This is not bouncing back to where I want it to bounce. The objective setter, whenever we destroy a tank in the tank spawner, it will update to check this objective. If we meet all 3 of our objectives, then using the next level determined by the level, that says what scene we need to move to. Past that, let's talk about the trees, and then we'll talk about the tanks. So there are 2 types of trees. There's the bare trees and the border trees. The bare trees is the main class. This is the ones that spawn in randomly and have a rotate orient to align themselves to the terrain. Whenever these are collided, they update their collision strategy to show off their particle effects. So for my collisions, I have the yes and no collisions. For yes collisions, we end up playing our particle effects and playing sound effects. We also submit entry for the objects, submit exit for the tree because it got collided with. For no collision, we do nothing because there is nothing to happen. The tree already got collided with, and they die in 1 hit. So but for the bare trees, whenever they collide, they do that. For the border trees, these ones are slightly different. These are the ones I use to make sure the player can't get out of bounds. So we have a border tree here. This will do nothing when we have collisions. And if I were to just quickly bounce on back to the sandbox to showcase this, you will be able to see that the tanks do not collide. If I run on over here, you can see that we have these brighter trees off in the distance. And also, because there are no tanks in my sandbox, the tracker just tracks the player. So yeah, once we make it all the way over, you can see that these tanks are stopping my movement. If I were to fire at it, it destroys the bullets, but the trees stay alive. So this prevents the player from going out of bounds. Trees come in a group. This group creates a specific assortment of random trees and an assortment of the border trees. Random trees are placed in random directions. Border trees are lined up surrounding the edges of the map. And then on destruction, it deletes both of those arrays. For the tanks themselves, for the tank spawner we'll start with. The spawner keeps track of the player and the HUD as well as the objective. It also has a factory for all of its tanks and is responsible for spawning them and updating the HUD strings to display the right tank count. This is also where we attach whatever camera we decide to the tank. So for instance, if I were to just go over here, we have a tank camera that just follows the tank. It takes in a position and rotation and updates itself. Um, it also is where we can get the player tank world and spawn in our tanks once again. This will increment our counter, insert them into the active list of tanks in the scene, initialize them, and update the sprite string. Reviving tanks is also where we can increment these values. This is useful mostly for the blue tank, as this is the one that will be respawning every time it gets exploded. And then when we destroy tanks, this is where we check our objective to see if we met it and can move on to the next level. We also have to update the HUD because we now have one less active tank in the scene. Whenever the blue tank is destroyed, the tracking tanks of the purple and yellow will have to update their movements accordingly. And then, yes, whenever the tank spawner is destroyed, any active tanks are pushed back into the factory so that it can be properly cleaned up. If I was to bounce down over to the factory over here, it's the standard object pool we're used to. We have our reserves here. If the reserves are empty, make a new tank. Otherwise, just pull one out of the reserves. Do that for all the different tank types, and then on cleanup, delete all of the objects. For the factory, we can get and return objects from that object pool, and when we destroy the tank factory, we clean up the object pool. The tank tracker, this was the thing I was talking about briefly earlier. So this has a 3D object and 2D object attached to it. The 3D object is at wherever the closest tank is. It will be hovering above it. And then the 2D object will take whatever point the 3D object is and move it into 2D space with a bit of extra clamping necessary if the screen position's Z value is found to be behind the player. So if it's ever below 0, we have an extra clamp to do to make sure that the sprite properly shows up. For determining the closest player, closest tank to the player, we will start off with the closest tank being the blue tank. If we find any active tanks, just a singular one, then we just say that is the closest tank. Once we know that we have a tank that is not the player tank, we will then be looping through all of the other active tanks lists, compute their distance between them and the player. If that distance is less than what we already have, then we have a new closest tank, update the pointer, and just do this for all the lists. Once we know that we found our closest tank, get their world, and that is the world we need for that tracker. So that's it for that. On to the tank types. There are 4 main types of tanks. There's blue tanks, which is what we use the WASD to move with. This is also where we update the camera and attach it. So this is the whenever we update the movement using WASD, right over here. Whenever we update that, we update the camera, and then we also have disconnect for destroying everything and recycling it. We have then we have the update collision strategy, similar to the trees. Tanks can only be collided with once per frame when it comes to the bullets. So we will run, whenever a bullet hits it, we will update the strategy to say don't hit it, we already collided. Submit our exit, damage the player, request a revive, and then play our explosion effect. So the 2 types are do and don't collide. The do collide updates the collision strategy. Don't collide does nothing. Respawns have a similar strategy of doing and don't doing an alarm. So this is where we do the alarm, and this is where we don't do the alarm. Whenever we request a revive with the respawn command, we will execute whatever alarm we have, either do or don't. If we do, then we request registry. If we don't do anything. And this prevents us from double registering our alarmable. Once our alarm goes off, we request the spawner to revive the tank at our specific iterator ID, or our specific type. So that's how the collision works. For the red tanks, these are our automated inputs. So we have initialization for it over here, and they just move completely randomly. They will move whenever the alarm goes off. They'll update their speed or their movement, their rotation or their movement. When they collide with tanks, they do their bullets. They do their collision. When they collide with trees, they apply a force to invert them. Whenever they collide with tanks, instead of inverting the force, they just invert their movement because they're going to constantly be moving in that direction. With the trees, at least the tree will be destroyed, so that's irrelevant. But for here, we need to invert the movement. For the purple tanks, we have the registry and getting the target world. These are the ones that track, so we take the destination that they want to get to, compare it to their position, get the vector between them, compare that vector with their forward, to see if they need to move backwards or move forwards. Do the same thing with their left to determine if they need to rotate right or left. They have 2 different ways of tracking. It's either they track the player or they track their home base. whenever the player is killed, they get the dead target call that updates the destination to be their spawn point, as well as disabling their firing so they don't accidentally shoot the player when they respawn. This allows the player to respawn with a bit of a wiggle room to move before the tanks start tracking them again. And that is that. So next up then is the yellow tanks, but let's just scroll down. They have the same collision of negating the forces so that they don't end up clipping through tanks, and updating the strategy involves saying they are not accepting any more collisions that frame, and then updating the emitter position for the particle effect. Yellow tanks are a mix of red and purple tanks, so they can either track the player following the dead targeting rule as well. They also have the update to collision. The alternative to tracking the player is automated inputs. So if they are automated inputs when they collide with the tank, they just invert the direction. Otherwise, they apply a force to negate it. Excuse me. Colliding with a battery, they apply the force. Colliding with a bullet, they update their collision strategy. Updating is just updating. And then they have all the alarms based on what they need to do. So they have the random alarms, and then they also have the tracking alarms. And then uniquely, they have this update state alarm. This update state allows them to determine what they need to do next. So if the distance between them and the player is within their tracking threshold, then they start hunting and they will start doing their calibrations. Otherwise, they will end up staying in search mode, where they will do randomized movements continuously. That is it for the tanks. The last thing is the aesthetic ones. These are just for the game over screen. For the victory scene, we just have a bunch of purple tanks that are exploded everywhere. For the dead tank, this is the game over screen where the blue tank has its parts spewing about. This is also where we use the pan around tank cam, where we just during update we just constantly update our rotation and translation to make it rotate around that point. And then also this was the top-down cam that's used in the title scene. It's just a camera that looks down. Not much to showcase there. But that is all the tank types. That's the tank factory as well we already showed with all the reserves and the requesting of grabbing all the tanks. Destroying the factory means cleaning up the tank pool. The last thing to talk about is the barrels and the bullets. So there are two types of tank barrels. One is for the player, the other one is for the enemy. They have some things in common, such as how they do their updates and draws. The enemy tank barrels, they will either have randomized movements, or they will be calibrating towards the player, depending on which type of tank it is. So randomized movements just randomized. Whenever the alarm goes off for firing, they end up firing. For calculating the player, it's just what the standard recalibration, get the vector between their position and the left to determine if they need to move horizontally, negatively, or positively. Get the vector for their up to determine if they need to move vertically, positively, up or down. Disabling firing, we have the canceling of the alarm. Disconnecting, we have the alarm cancels. For the player tank barrel, this is the one that has unique properties to it. So the tank barrel here is relative to the mouse pointer. So we convert the 2D pointer of the mouse to 3D space. We have a sphere that is centered around the tank, and then we do a B-sphere, the segment intersection between the far and near point of the mouse. We grab those two intersection points, create a path between one of them, see if that one is the one in front or behind. Determining that, we will determine which rotate orient we need to do, whether it's with path A with the intersection 1 or path B with intersection 2. And then we rotate the barrel to face that mouse. And then we set the world to be at that world position. Lastly, we have the different bullet types. So similarly, this has the do and don't collision strategy that I've been showing a bunch already, of updating the collision strategy once and then never again. Or once per frame specifically, and then updating it once we recompute it. Here's the object pool for the bullets once more. So we have enemy bullets and player bullets. The player bullets, we preload some of them for the bullet object pool. And then we create player bullets and enemy bullets, recycling them, all of that. We do that inside this bullet factory, which is stored inside the appropriate barrel. Right over here, this is where the factory is stored. So we have player bullets and enemy bullets. So also that's not the barrel, this is the barrel. Here's the factory. Looked at the wrong one. So player bullets and enemy bullets, they behave pretty much the same. The main difference between them is that they are made up like this so that I can set up collisions so that enemy bullets do not collide with other enemy tanks, and player bullets can never collide with the player tank. This allows me to get away with not having to do one of my conditionals that I had right over here, where I had to keep track of the tank firing the bullet to make sure that it's not trying to collide with itself. by specifically setting up the collision pattern to avoid this, I don't have to worry about it. And I believe that is everything. The last thing is talking about collision with the terrain. So for the collision with the terrain, I have to check to see if the bullet ever goes underneath the terrain. If the bullet does, then it's considered a dead bullet, so we treat it as if it collided with something, and then we play the dirt particle effect. And that is everything. Same thing over here.